So what we're going to look at now is basically what we've been doing in our heads graphically with our balance beams. We're going to be rearranging equations, and I put manipulating up there because I think it's exactly the same thing. You're manipulating this math to make it do what you want. So when you manipulate a younger sibling and make them give you the best dessert, you're basically doing the same thing but with the equation we've got here. Okay, and we're going to give you a process that you will use over and over and over again. You'll be using this skill in year 11 and year 12 and beyond. Probably the most important thing I'm going to teach you in the next 3 to 4 weeks and the last 17 weeks. So we follow 3 essential rules. We're doing this. If you follow these 3 rules, life is a lot easier. The first one, Sienna, is don't break the balance beam. What does that mean? Don't break the balance beam. Georgina?
Make sure that the sides are even.
Make sure the sides are even. And if they start even, can we do something to one side and not to the other side? So whatever we're doing to one side of the equation, we have to do to the other side of the equation. Now I've represented that with a little balance beam. Do you think that in year 12, I get my year 12s to write little balance beams under their equal signs? No. Why do you think I'm making a point of doing it here?
So we know.
Because that's what's happening. An equal sign means that on either side of the equation, both things are equivalent. Both things have the same value, like a balance beam. Follow the order of reverse BOMDAS. So what's BOMDAS? What do we use BOMDAS for? Solving problems. So when we're solving, we use BOMDAS. When we're rearranging and manipulating, we use reverse BOMDAS. What do you think that means?
We start with the S instead of the.
Yep, so the first thing we're looking to fix is our subtraction and our addition. Then we go to multiplication and division. Then we go to orders of powers and brackets. Does that make sense?
Yes.
I like to think of it as wrapping the present versus unwrapping the present. When we're solving, we take the layers off, start with BOMDAS or brackets all the way down. And what about when we're wrapping the present? Do we start with the outer layer? Or do we start with the inner layer? So when we're rearranging, we're undoing it. Does that make sense? So think of it like wrapping a present or unwrapping a present. The only way we can manipulate or rearrange an equation is by using opposite operations. So if I want to get rid of an addition, what should I do to both sides? If I want to get rid of a multiplication, I should? Does that make sense?
Yeah.
So what's the opposite operation of plus 2?
Minus 2.
What's the opposite operation of divide 4?
Times 4.
Opposite operation of minus 17.3.
Plus 17.
Do you see the point I'm trying to make? So whatever you do, as long as you do it to both sides and we use the opposite operation, we don't get ourselves into trouble. So, up here we go. The goal is to get our pronumeral by itself. And if we think about it from the point of balance beams, if I want to know, for example, this is an equation where I've basically said 4 fishies plus $3 equals $11. Have I written the dollar signs in there?
No.
Not required. I'm just giving us a framing for the problem. So if on one side of my scale I've got 4 fishies and $3 and on the other side I've got $11, how do I find out how much a fishy costs? What do I need to do?
Well, you gotta. So you know that one side equals 11.
Yep.
So you gotta find out. So 4 fish. You gotta find out what 4 fish equals. But so you have to 11 take 3 and then 1.
So I subtract 3 from this side.
Yeah.
Am I all good?
No, you have to do it.
I have to do it to the other side too. Why do I have to do it to the other side? What rule?
Rule 1.
Rule 1. Okay, what happens to the 2 3s here? They live merrily, plus 3 minus 3? Cross them out. So I've got 4 fishies equals 11 minus 3. Are my balance beams the same?
Yeah.
So I can draw them back in. I've kept my balance beams happy. What's that 4 fishy mean? What does that mean?
4 lots of fish.
What's 4 lots of mean? Thank you, Sophie. What's lots of another word for? It's an operation, a mathematical operation. Multiplication, very good. So in here I've got a secret, it's called a math convention. but there's a secret little times in there. How do I deal with 4 times fishy? What do I do now to help unravel or manipulate this equation to get fishy by itself? Jack?
Divided by the answer.
Divided by the answer. Maybe we can work on our language a little bit there. I think you're right, but you need to work on your...
Find an average from...
So what's the operation between 4 and fishy?
Times.
What's stopping me from getting fishy by itself? Why is my fishy not by itself? So how do I get the 4 on the other side?
Put it on the other side.
I just move it on the other side.
Yeah.
Look, 4. There, answer's done, right? All good. Manipulating 101. Well, let's start with what's 11 minus 8. Let's start with that. 11 minus 3, sorry. 11 minus 3 is 8. So I've got 8 equals 4 fishy. Do we know how much fishy equals?
No, but you do.
Well, in your head, do you know how much fishy equals? How much does a fishy cost?
$2. Because 2 times
How much does a fishy cost?
$2.
We know that because 2 times 4 is?
8.
Now, what's the operation going on between the 4 and the fishy? How do we undo a multiplication? Divide. So what do I need to do to both sides? Divide by 4. Have I kept my balance beams?
Yes.
Has it done the same thing to both sides? Fishy equals what, Lawson?
2.
Does that make sense?
Yes.
We've followed reverse PIMDAS. We've kept our brackets the same. And to cancel stuff, to get the fishy by itself, the goal the whole time is to get what by itself? The pronumeral. What's our pronumeral here? Would it matter if it was square? Would it matter if it was X? Would it matter if it was circle with a smiley face? Doesn't matter what the symbol is, it's the unknown in the equation. And we're trying to find out what that is. Cool? That's pretty similar to how they used to figure out the mass of something. Who's seen how the old balance beams work? When you put a certain, you'll get your amount of apples and you put them on the scale. What do you do to the other side? You're putting enough weights on the other side to make them balance, correct? Pretty similar, isn't it? Now we've got scales, we don't need to do that. Okay, very good. And we've got the ability to calculate best buy, so we don't need to worry about that. Sweet.